Hi again. Alright, so in this video we are going to just quickly review simplifying expressions that have more than one variable term, going through the different names of the expressions and different parts of an expression. Okay, so I took the examples from page 220. This first one is number 23, parts of number 23 that I'm going to do. Okay, so as you can see, this one compared to the expressions, the equations in the last video, this is just an expression. There's no equal sign. There's no way I can solve it for a certain variable. The best I can do, the direction would be just to simplify. Okay, so I shouldn't be getting any solutions. I should just be trying to combine anything I can. So simplifying, there's two main things you do. One is if you have to use the distributive property to get rid of parentheses. And then the next is to combine like terms. So this doesn't have any parentheses I can distribute. So I'm going to start picking out like terms. So remember, like terms are ones that have the exact same ending. Okay? Ending, so this one I would say the ending is A. If another term in here had an ending of A squared, they would not be like. The only thing that can be different is the number in front, which we'll write down later on, is called the coefficient. So I'm kind of just circling and just showing you, okay, so the ones in white are like, and then these ones in pink are like. And notice when I'm circling the sign in front of it. So with that negative 10b, I boxed in the negative as well, because that's part of it. So my next step is going to be to actually write my simplified expression. Okay, so I have 3a minus 5a, so combined total, that gives me negative 2. Still a. Notice that doesn't change. Okay, this would only become an a squared if I was multiplying these. Okay, which right now I'm just trying to add or subtract, so it stays the same. Just like when we do things with, say, perimeter and area. When I have a perimeter and I add up all my feet, I still just get feet. Whereas with an area, when I multiply, that's when I get feet squared. So this is the same exact thing. So when I combine 3a and negative 5a, I get negative 2a. And now when I combine these, that 7b and negative 10b, I get negative 3b. Okay, so this right here, just to kind of go over some of these some of the terminology, this right here that we have left with has two terms. Okay, terms are the parts of the expression that are separated by either a plus or minus. So this gives me one term, and this gives me another term. Okay, so let's look at another one I have here. Okay, so this one, same thing. Okay, we're going to just simplify. There's no equation. So I see that I have a 9x, a minus 7x, and a 5x. Those are the ones that are like. Okay. This 3x squared, that's not like, because it doesn't have the exact same ending. Okay, so what I have, let's see, the 3x squared I'm going to bring out front, and you'll see that done a lot of the times, where you put them with the highest power of the variable, and then it goes down from there. So now let's see how many x's we have. 9 of them minus 7 of them leaves me with 2 of them, plus 5 of them leaves me with 7. Okay, so I have 7 x's. Okay, so again, this one, just like the other one, this one has two terms. The 3x squared is one term, and the 7x is another term. Okay, it has no constant. Okay, constant is a value in there that's not dependent on a variable. It stays constant, which would mean if this said 3x squared plus 7x plus 1 or plus 2, that would be the constant, but this doesn't have one at the end. And then a lot of times another terminology we use is what are coefficients. So let's say I asked for the coefficient of the first term. Okay, the coefficient is this number in front. So if this is my leading term right here, it's my leading term, my coefficient is a 3. If it was negative 3x squared, then my coefficient would be a negative 3. It tells you how many of that term you have. Things you've heard before. Okay, so the coefficient of the second term, if I were doing that, would be 7. Alright, so that's as simplified as I can get. This would have been my answer if they said to simplify. Okay. I have next? Okay, so this one right here, I want to just show you the difference. Sometimes you're asked to distribute. So this is the example I'm going to look at. I'm going to write it out two ways here. I'm going to write it like that, and then I'm going to write it out like this. This is virtually the same problem. One is doing something in one direction, and the other one is doing the opposite direction. So when we distribute, it's just meaning if I have 5 times this whole quantity, it means I need to do 5 times each one. Okay, so I'm sure you've done this before. We end up getting a 15x minus 15. So if we were asked to distribute, we'd be done here. We're done. Sometimes we're asked to do just the opposite direction. So this one we multiplied out the 5. In this one I actually am starting with the answer, and they're asking me to find the GCF, meaning the greatest common factor. So we look at the 15x and the 15 and we say, what goes in, what divides, what is the largest number that divides into both. Sorry, this is messy. So we kind of already know it from the last one, but on this one, oh, I made a little mistake here. Let me go back. This should have been a 5. See, if we were in class, she would have corrected me. Oops. Okay. So I had meant to have the same problem, but let's just keep with this 15x minus 15. So they're not the exact same problem. So if I had to find the GCF of this 15x minus 15, 15 actually goes into both. So that's what I'm going to undistribute. That's how I kind of call this, is undistributing. Meaning just do the opposite order of that. So I'm going to take the 15 out, divide it out, and see what's left. And what would be left is x minus 1. So the idea is if I were to now redistribute that, I would be right back up to the beginning. Because remember, now I did do, these are two different problems. Since I had made that one little mistake on that one, it's different. So now the next example I have here is going to just practice that distributing. So the next one, this came from number 25H. So we're still on that same page. We're on 221. Okay, and this one, the directions would be to simplify. Again, it's not an equation. So the best I can do is simplify this. So the first thing I would do is distribute anything I can. So I'm going to do both of those. So I'm going to end up getting a 4x plus 8 plus 5x minus 5. And so now we're kind of back to our first slide where now we just combine like terms. So I see this and this are like. So those give me 9x. And then I see this and this are like. So those get me plus 3. So total I have 9x plus 3, which I won't combine to 12 because these are not like anymore. So that's the best I can do. Okay, so that's simplified all the way. Okay, this last one. Same kind of idea. Again, the directions would be to simplify. So let's see, first we're going to check if there's anything to distribute, which there is, okay. So here I'm distributing not only the 3x, but the minus 3x. This whole thing, this whole piece I'm going to distribute to there and there. So let's see what we get. So the 2x squared is going to stay right up in front. Alright, and now I'm doing negative 3x times x. So I'm going to get a negative 3x squared. Just like feet times feet is feet squared. Excuse me, feet squared. X times x is going to give me an x squared. And now I'm doing the 3x, negative 3x to the 3. And that's going to get me a minus 9x. Alright, so now that I'm done distributing, I'm going back, I'm looking for like terms. And so this, again, it's got to have the same base, same exponent and everything. So this and this are like. So when I combine them, I have 2x squared. I have 2 of something minus 3 of something. Gets me negative 1 of them. So I can have the 1 like this if I want to, but a lot of times you're just going to see it like this, negative x squared. and then minus next at 9x is on the end. So let's just kind of recap that this would have two terms. If this is my answer, my simplest form that has two terms, if I were looking for the coefficient, well, the coefficient of the excuse me, of the first term would be a -1. The coefficient of the second term would be a -9. So if you were being asked the coefficient, you would have to know which term you're looking at. So when they're in order from biggest power of x to the lowest, then you can call them first term, second term. So that's pretty much the gist of simplifying these. Next class, what we'll do is we will solve equations, not so much just like the basic ones, but ones that have these steps built into, where we have to sometimes simplify each side of the equation before we can actually solve it. So at this point, you should be able to do that second, or I guess it's probably I think it's the second section of homework. That's really not due till next week, called the basic solving equations and simplifying. And again, let me know if you have any questions by email. Enjoy your few days off.